All right, gang, here we go, page 2. All right, so same thing. All right, we're still using that same triangle, those same formulas, right? I can just take page 1 and put it behind page 2. Can you see that? There it is. Okay, so these same formulas, Gay-Lussac's, Charles, Boyle's combined, and then of course Pivner. All right, so those are the same ones we're using. So let's go through 6 through 12. I'm going to move a little bit faster. Pause it and repeat if you need. So as I looked, it says that you have oxygen gas in a balloon. I have room temp. We convert it to Kelvin, add 273. I have a volume. Then I put that balloon in the freezer. That has a colder temp. I add 273. What's the final volume? So what I have temperature and volume. So the equation that deals with temperature and volume, who is that now? That's Charles, right? So that's V1 over T1 equals V2 over T2. All right, so I can plug that in. That would be 12 liters to start, and 298 Kelvin equals V2. I'm looking for the final volume. That's V2 over the final temperature, which is 273. Now what do? I cross multiply. I take 12 times 273, and I take 298 times V2. All right, so I have 298 V2 equals, and now I go, here we go. I got to do the math. I go 12 times 273. That equals 3,276. How do I get V2 by itself? I divide by 298. I divide by 298. And if I do that, divide by 298, I get V2 equals is that right? Yeah, that should be right. 10.99 liters. Volume, so it's liters. Okay? That's number 6. Here we go. Number 7, moving right along. Awesome. See you tomorrow. What must the pressure be? So we're solving for pressure. I have volume in liters. I have temperature in Kelvin. I have moles. Holy cow, moles I know right away. Oh, that's Pivnert. Moles is the giveaway. Remember, R is always going to be 0.0815. So I didn't give you R, but that's a constant that I will give you. You need to know that. That's on the back of your periodic table. If you look, here we go. Here's your periodic table. Okay, here's the gas laws. There's the R right there. 0.0815. Okay, so now I just got, what am I solving for? I'm solving for pressure. So I want to get rid of V. What do? Divide by V so I can cancel. But then I got to divide this side by V. Then I have P equals nRT over V. Then I just plug in what I got. N is 2 moles. R is, again, 0.0815. Temperature is 293. All over volume, which is 5.1. If I do that, this times this times this, divide that all by 5, my pressure should equal 9.43 atm. There's number 7. That was Pivner, my ideal gas law. All right, let's look at number 8. Moving along. If you need, again, to pause and rewind, do that. We're going to keep plugging away here. Nitrogen is in a steel container. Pressure, temperature. What will the pressure be? So my answer I'm looking for is I'm looking for P2. That's what I'm solving for. And then again, temperature. So I have 2 pressures and 1 pressure and 2 temperatures. The guy who did pressure over temperature, remember that's Gay-Lussac. So it's P1 over T1 equals P2 over T2. And again, I'm solving for P2. So I could write that in a different way. P2 equals P1 T2 over T1. And then just plug them in. If I do that, my P2 equals 164 ATM. And we know it's ATM because atmosphere is pressure. That's number 8. Again, I'm not going into as much detail. How did I do that? I just cross-multiplied them again. Right? I plugged them in. I cross-multiplied. All right, that should be 150. That should be 300. That's P2. That's 328. Then cross-multiply, and divide out the temp. All right, let's do number 9. Sample of gas occupies volume, temperature. What will be its volume? So that's V2. That's what I'm solving for. And again, a second temperature. Who's the volume temperature guy? V1 T1 equals V2 T2. You guys remember who that is? That's Charles. So I just plug in what I got. I want to solve for V2, so I want to get it by itself. I'm going to multiply by T2. Now they cancel. Multiply by T2 on both sides. If I were to write that, it's V2 equals T2 times V1 over T1. Now I can plug in my numbers, right? What was my final temperature? 300. What was my initial volume? 6.8 liters. What was my initial temperature? 600 degrees Kelvin. Now I can cross out kelvins. All I have left is temp. 300 times 6.8. Divide that by 600. If you did it right, volume 2, the final volume, should equal 3.4 liters. Okay, 3 more. Let's keep plugging. What pressure? Okay, so I'm looking for pressure. What do I have? I have moles. Oh, stop. Moles. That's easy right now. Moles, remember, is N. So now it's Pivnert. PV equals nRT. I'm solving for pressure. All right, but I have moles, so I know I have Pivnert. If I want pressure by itself, I got to divide out the volume. If I divide this side, I got to divide that side. If I write that, P equals nRT over V. Remember, R is always our constant. Again, if I look at my, wreck and shop over here. If I look at my periodic table, look at my gas law. R, again, constant, 0.0815. Okay, so I can just fill in the numbers. Well, how many moles? 0.450 moles times 0.0815 is R times my temperature, 298. Divided by my volume. Now, we would like to change milliliters. Remember, Pivnert, we want to always get into liters. So I just need to take this decimal to change it for milliliters. 1, 2, 3. So liters, it's going to be 0.650 liters. That times that times that divided by that. If I do that right, my pressure should equal 16.9 ATM. 2 more. We're doing great. Let's keep plugging. All right. Determine the volume occupied by, what's that? Shoot, that's easy now. It's Pivnert again. We got moles, it's Pivnert. We know that. I want to solve for volume, so I got to get rid of P. What's my new equation? V equals, cross those out, nRT over P. And then I plug in what I got. What's N? 0.582. What's R? Always, R is 0.0815. What's T? 288. What's pressure? 16 ATM. And that's going to equal V. So if I do that, plug that in, V should equal 0.0221 liters. Last one on this page, number 12, temperature. What is the temperature? So now I'm looking for temperature. Gas inside, I got volume. I have mole. Oh, there it is, moles. What do I got? Pivnert. But now I'm solving for temp. So how do I get temperature by itself? Can't I just divide out N and R? Cancel, cancel, but then I also have to do this side, N and R. So what's my new equation? T equals PV over NR. Now I just plug them in. The one thing I need to change, remember, volume, we would like that to be in liters. So how do I change it from milliliters to liters? I move the decimal point over 3 spots. 1, 2, 3. So that's equal to 0.750 liters. That will go in here for volume. Okay, so what do we got? Pressure. Okay, pressure is 1.2 atm. Volume is 0.750 liters. N, is 0.015 moles. And then R, as always, is 0.0815. I do that to solve for T. If I calculated that right, I got 730.8, and it's Kelvin because it's the temperature of a gas. That is page 2, and we're done with page 2. We got one more page, ladies and gentlemen, and then we're done.